log base 4 of 1/2. Log base 4 of 1/2 equals a. I have no clue, but I know how to change this into an exponential equation. Good. Now I'm hoping, because I don't know what else to do yet, I'm hoping that both sides have the same base. So the left-hand side will be 2 squared everything raised to a, and the right-hand side will be 2 to negative 1. Perfect. So then the left-hand side is 2 raised to a, the right-hand side is 2 raised to negative 1. Two numbers are equal, and they have the same base. So the conclusion is that 2a equals negative 1, so a equals negative 1/2, so that's the number here. So log is a power. We raise 4 to get 1/2. So log is this number, which is a power, that we raise 4 to get 1/2. Okay, let's look at one of the 25s, A, B, or C. Please choose. You want C, which is e to natural log of the square root of 5, correct? This is a formula. I just don't want you to memorize the formula. I just want to show you what it is. Okay. So this is a number. Okay, B is better and easier identifiable, not confused with 9. So I'm going to use B. Okay. I have no idea what this is. But obviously, you could say it's a log equation. I would say no. No. It's first an exponential equation. E raised to equals a number. And you can say, but it's combined with a log. I would have to say yes. But initially it's an exponential equation because I have a base raised to log equals a number. So let's change this into a log equation. So preparation. Preparation is very important. So I will have to have, I may erase what I have here, but definitely that's my first stage. Log of some number applied to some number equals some number. The reason why I'm going to erase, yes. Go ahead, Paul. Yes, yes. I'm just, exactly, that's what I said before I even started, right? I said I may have to erase this. I'm not going to erase it because this is a reminder what it means. So log in some base applied to a number equals a number. Yes, the reason why I'm going to erase it is because the base is E. So this should be E. This should be natural log of the square root of 5. So this will be B, right? E raised to this equals B. The reason I erase it is because I'm not allowed to, although it's not a mistake, I'm not allowed to write log base E. I have to write ln B equals ln the square root of 5. Agreed so far?
Yeah.
Okay, so now I'm back. Now if I ask you what type of equation it is, you must say log. Perfect. And I'm saying this to you. Two logs are equal, and they have the same base. What has to happen for these two to be the same? And remember, these functions are one-to-one. There is no
square root of 5.
There is no other way. So in general now, the formula is, I'm not going to test you on this because you're not going to see it again till Calc 2. And the general formula is A raised to log base A of x is, compare and tell me what I should write. compare this to that, and tell me what will be here. So compare this to this and tell me what to write here.
X.
Of course. As long as these two are the same base.
Right.
This collapses. It's not applicable, in other words, if this is base 5 and this is base 3. The answer will not be X. But as long as they are the same base, and you notice here, here's E and here's B. E. That's why the answer is X.
What if you have different base?
Then I can use the formula. I can calculate whatever you give me, but not using this formula.
Oh, I see.
Okay, moving on to the next set. 29 through 36.
B.
Okay, 30B. B. So log base 10, it shouldn't be, but they started writing that at the beginning, so we don't forget. But there is no need to put log 10. It's like there is no need to put the square root with 2 as the index. So we're asked to find x. Find x. I don't know what this is, but I know that it's a what type of equation, and it can be easily changed into, good, I'm ready,
10.
to the
X.
equals, very good. As long as I can present both sides with the same base, I'm in business. So the left-hand side is 10, and the right-hand side base 10, I'm hoping, and the power will be, that's it. Again, I'm back to an exponential equation. Two numbers are equal. They have the same base. What happens to the exponents? X equals -1. So please choose another. And using the calculator to evaluate expressions, let's choose one. You already seen that a minute ago. 32. 32a. Log base 4 of 2 is x. Log base 4 of 2 is x. It's the same problem. I would have chosen 36, but since we started, let's finish it, and then we'll look at 36. So I don't know what this is, but I know it can be changed. 4 raised to x equals, good. I'm in business as long as I can present both sides with the same base, and I can. 4 is 2 squared, so 2 squared exactly equals 2. Two numbers are equal, and I'm happy, and luckily they have the same base. So then the exponents must be, so then x equals 1/2. Okay, let's look at 36 because it's different. Log x, base x of 6 equals 1/2. And now is the time, I already repeated it many times, but it's not clear maybe, how we read log base a of x. Log base a of x. Log base a of x. So this is not connected, of course. I'm sorry, I just put them too close to each other. So log base a of x. So I know that this is a log equation. I have no idea how to solve it, but I do have the knowledge, or I know that it can be replaced or converted into, good. What does x to 1/2 mean? Oh, and by the way, what type of equation did I change it into?
Square root of x.
Correct. This is not an exponential equation. This is a square root of x equals 6. Awesome. What type of equation is this? How do we call it? If it has a radical and x is under the square root. Perfect. How do I solve a square root or a radical equation?
Square root
Of
x.
course. So then x equals 36. Because I squared, I should go back and check. Log base 36 of 6. This has to be a number that is positive. It cannot be 0. It cannot be 1. So 36 raised to 1/2 is indeed 6. Good. I didn't forget, we still have to graph this function, but I would like to look at finding the domain. And then we'll graph both shapes. We graphed them last time, but I still want to graph them slowly in transformations. Very, very important type of problem, 63 through 68, page 323. And then I would like to show an application. And just with simple log functions, you see absorption of light, carbon dating, bacteria colony, investment, charging a battery, difficulty of a task, and goes on forever. Okay, so first let's look at, so maybe we should create a short log or a simple log here of functions that have problems. So I'm going to say functions with restrictions, which means x cannot be any real number. Functions with restrictions. Of course, the restrictions are on x. Square root. Rational. Log. Tangent. Secant. Cosecant. Cotangent. This is the list of functions with restrictions we looked at this semester so far. We don't have other functions actually beyond this. So it was,
with a base x, right?
yes, I didn't put anything. I didn't put any x anywhere. Any base, log of any base. If it's between 0 and 1 or it's between 1 and infinity, they all have to be defined on 0 to infinity. Yeah, okay. Then I have to put it everywhere. Okay? So, for example, let's look at 68. We have a function denoted by h of x, which is the square of x minus 2 minus log base 5 of 10 minus x. So what is this function? Can anyone describe this function? What does it say to us? Let's say I created this function. I didn't. But let's assume I did. What would you say to me? I know how you created this function. You took
Log and square root function.
and you subtracted them.
Yeah.
So you used an f and a g and you subtracted them. The first one is a square root and the second one is a log. When we add and subtract fractions, multiply and divide a function, what do we have to find? Because if they don't have it, this function means nothing. Awesome. Common domain. If they don't have a common domain, what did I create them for? There is no x that I can plug in.
Yeah.
If I cannot find an x that I can plug in both, and the function exists, I can subtract two numbers, and one exists and the other one doesn't, or none of them exist, then the function means nothing. Good. So I have to find the common domain if there is one. Good. So how many restrictions or conditions you will give me? So this one is this type, and this one is this type, both with potential problems.
Isn't the problem on the log only when the base is 0, 1, or negative?
But this is the base.
Yeah.
This is the argument.
So x can be any.
No. This is the base. So A is the base. It has to be greater than 1 or between 0 and 1.
Isn't that 5?
Yes. So it's a number greater than 1.
Yeah.
So the log exists as long as this quantity is what type of number? Exactly. Which means if this quantity is not a quantity between 0 and infinity,
Gotcha.
log does not exist.
Gotcha.
So let's start with the first function. What do I have to write for the first function to exist?
X minus 2 is greater than 0.
Or equal to. Because I can take the square root from 0. But here, log applied to 10 minus x. What should 10 minus x be? Exactly. Why cannot write greater than or equal to 0? Because at x equals 0, log function has,
That's the vertical asymptote.
it's not defined. So if you ever have any doubts, go to your calculator and put log and put 0, close the parenthesis. What do you think you're going to get?
Undefined or error.
It's going to scream at me. You are plugging something that you can't, right? Because we know that log function has a vertical asymptote there. Good. So I solve this as x greater than or equal to 2, and I solve this as x less than 10. I graph those two solutions because what am I doing with these two? What will I be doing with x greater than or equal to 2 and x less than 10?
Find the intersection. Of the
Exactly, because I have to find the territory in which I can tell you I can evaluate this function if you give me x values between this and this. If you give me something outside, the function doesn't exist. So greater than or equal to 2, remember I don't care for units. This is only used to help us find the domain. And less than 10, if there is no common domain, function h means nothing. So what is the domain of function h?
right here.
Yes?
2.
Yes?
10.
That's it. Where both colors exist. The orange and the green are there together. So now if you ask me to evaluate this function for any number between 2 and 10 but not 10, I'll say okay. But if you say plug in 0, I'll say sorry. I can't. I can plug 0 in here, but 0 minus 2 is negative 2, and the square root of negative 2 is not a real number. Okay, one more. Let's say 66. F of x equals natural log x minus x squared. And then I like to look at a word problem. The same question here. This time I'm going to ask you, how did I create this function? Oh, of course I didn't. But how did the author create this function? What did he do? In the previous function, you correctly identified it. You said you took a square root and you took a log and you subtracted it.
Right.
Okay, how did the author create this one, though?
F of g. Or
Exactly, a function composition. What is the inner function? One option. What is the
x minus x2 squared.
What is the outer function?
Log of x. Natural log.
Very good, awesome. Now once you understand this, you have little difficulty in Calc 1 because you're going to have in Calc 1 to differentiate this, and that will be the chain rule. So that's very important to understand, the inner function and the outer function. Good. So in order to find the domain of this function, what do I do?
X minus x squared must be greater than 0.
Awesome. It's a log. It's applied to a quantity. This quantity has to be strictly greater than 0, whatever it is. Perfect. Okay, now how do I solve this? And remember what we ask ourselves first. What is it? And when I'm asking myself what is it, and I say quadratic, then I'll say I cannot separate the terms. No way. What do I do? And also another bell rings in my head. Don't divide. You cannot divide by anything. Yes. But first, remember, simplify. I refuse to work with a quadratic quantity in this form and with a negative leading coefficient. I have to do some work if I want to simplify my problem that I have to work with, right? The inequality. So rearrange it, multiply both sides by -1, and then factor out what? Yes. So these are valid in everything. So factor, simplify, descending order, factor out -1. This is always the same pattern, the same theme. So negative x squared plus x greater to 0, -1, x squared minus x less than 0. And yes, x minus 1 less than 0. Now I have to think, okay, it's quadratic. I see two factors. What do I do with this? How do I solve this? I've done this for test 1. What did I use to solve this? I can divide. It's a factor. It's a product. I have 0 on one side. How do I do this?
The table.
Thank you. The table. Negative infinity to infinity. The first factor is x. The second factor is x minus 1. And what is the last row? Exactly. What numbers go in the chart?
0 and 1.
Exactly. In that specific order. Where is the 0 for x?
0.
I know it's a silly question. Where is the 0 for x minus 1?
1.
And what happens here and here with the product?
It's undefined then.
It's not the ratio. It's a product.
0.
Yes.
Oh,
Good. So now I study the sign. I know a lot from polynomials. This is linear. I know the end behavior for both of them. If I know the end behavior, I know their sign. So what is the sign for the first? Right? Sign for the product, for the first, for the middle one, and for the last one. So what do I want?
Less than 0.
Yes, which means which sign? Exactly. So what is finally the main of this function f?
0 and 1. Print.
Yes. So if you want to graph this function, it will have a vertical asymptote at
0.
exactly It will have a vertical asymptote at, good, let's graph it, just for the sake of the argument. So y equals, because I want to convince myself, I want to see, just to check and see if I did this correctly. So x minus x squared. See how it's reflected in the graph. And I'm going to use Zoom 6. I know it's lying. It has two vertical asymptotes. It has to do this, not this. Right? If I zoom in, I'll get a better graph. So I'm going to change the viewing window between -1 and 2. And let's see what happens now. Still kind of lying. I know it doesn't stop here. I know it doesn't stop here.
Yeah, it doesn't.
It has to continue forever because those are vertical asymptotes.
Yeah.
So do not trust this. Trust your understanding and your knowledge. Okay, moving on.
So even if you go
Yes.
to the table and put like
Exactly.
0.00001.
Right. Yes, and you will get negative infinity. Correct. Good. So let's look at a word problem. Let's say bacterial colony, 88, on page 324. And then we'll look at the graph and transformations. T equals 3, they say. Log n divided by 50. Everything divided by log 2. All these are common logs. There is no base, so it means base 10. Let's see what they want. A certain strain of bacteria divides every 3 hours. If a colony started with 50 bacteria, then the time t in hours required for the colony to grow to n, uppercase N bacteria, is given by this. Find the time required for the colony to grow to 1,000,000 bacteria. So n is the number, t is the time, find the time required for the colony to grow to 1,000,000 bacteria. So all I have to find is t. This should be t of n, right? So I should find t of 1,000,000, which is 3 log 1,000,000 over 50 divided by log 2. Be very careful how you plug it in. So let's do this together. So we have 3 outside. We have log. And we have in parentheses 1,000,000 divided by 50. Close the parenthesis. And divide by log 2. Close the parenthesis. And press enter. T in the problem is given in hours. So approximately 43 hours. So I will say T approximately 42 if you want 0.86 hours. So this bacteria divides in every 3 hours. Half. So, and so on and so forth. And half again, and half again, and half again. And in 42.86 hours, it will get to be 1,000,000. Okay, so we're ready now to look at 2 log functions. Give me a function with a log with base greater than 1, and another function with log base between 0 and 1. So we can look at 2 different graphs. Both shapes. We'll do a shape for base greater than 1 and a shape for base less than 1.